Hello and welcome back to Precalculus1 for one last time. This is it. Partial fraction decomposition, and we're done with Precalc1. After that you have Precalc2, then Calculus 1, 2, 3, differential equations, linear algebra, and then another 10 years of mathematics to kind of catch up with what's been done today. If you're interested. Or you can just tap out right after whatever course you want. Partial fraction decomposition is going to be used in Calculus 2 in a section called partial fraction decomposition, where you learn integration technique that involves what we're going to learn today. No calculus though. And then in differential equations, you are going to have a chapter on Laplace transforms, where partial fraction decomposition is important for inverse Laplace transforms, to go back to the time domain from frequency domain when you do the transformation. So this is going to be useful later. Now, what is partial fraction decomposition? It is like undoing addition and subtraction of rational expressions. So, in algebra, you have 3 over x minus 2 plus 6 over x plus 5, and you want to add these. Well, the common denominator is x minus 2x plus 5. Then you will have 3x plus 15 plus 6x minus 12 if you do the cross multiply. And you have the answer of x minus 2x plus 5 in denominator. In the numerator, 9x plus 3. So this is what we have in algebra. So what's the new thing? The partial fraction decomposition. Partial fraction decomposition is asking you to take this 9x plus 3, x minus 2x plus 5, and to somehow get 3 over x minus 2 plus 6 over x plus 5. So this is what we are doing now. Partial fraction decomposition. I have a single fraction that is decomposed into 2 or 3 or whatever amount we must have, right? So partial fraction decomposition, and each one of these is partial, right, in comparison to the whole thing you had. So you can, the title makes sense. So this is what we have. We have partial fraction decomposition, which is a procedure that will take a rational expression that has some factors in the denominator and break it into multiple fractions so that you can do whatever you need to do later in mathematics. So let's validate this procedure. Before I actually go there, I just need to talk about the setup. So these are the formulas which allow you to set up your problems. What you are going to have is I just put blah because it doesn't matter what is in the numerator, and then you have denominator as x minus c. So you have some kind of linear denominator. This assumes just x or x minus 5 or x plus 10, right? So all of those types of whether you have c as positive or negative number including 0 situations are set up as constant a over x minus c. So if you see a linear factor, that's the setup. Again, numerator doesn't matter, so I'll put blah. And then I have x minus c squared, which is repeated. Well, that's going to be a over x minus c plus b over x minus c, everything squared. Again, this is a setup. We are going to see exactly which way this is used. 2 more. So there are 4 of these guys. Blah of ax squared plus bx plus c. So I have a quadratic now, and I cannot factor it. Obviously, if I could factor it, I would use the ones above. Now this is going to be ax plus b divided by ax squared plus bx plus c. So the difference between lowercase letters and uppercase letters is very important. They're not the same. So hopefully you have the habit of separating what's lowercase and what's uppercase. And the final one is when it's again repeated. It's very easy to remember these because they're very systematic. I'll show what I mean. There we go. So these are the 4 formulas which you are going to use to decompose problems. Now, the first observation is, if these guys are linear, you only have a and b, no x values. If they're quadratic, then you go one order less, and there's your ax, and there's your cx, and so on. So you see that the order of the numerator is always by 1 less than the order of the denominator. And then you also see the repetition. So if you have the x minus c squared, you have ax squared plus bx plus c squared, which is a repeated this one, right, and repeated that one. You write 2 of these guys. Oh, that was my square. They have to look the same. There we go. Much better. See the square over here? So the first term and the first term look the same, and then the second term has different cx plus d with everything squared. The same thing happened here. These formulas are not difficult to memorize. Plus, I mean, in Calc 2 you will have to know them, and differential you better know them. But, you know, we can deal with this. What was that problem? I had 3x minus 9. Was it 3x minus 9 or... that's what I said, 9x plus 3. Please pay attention. And then what else do we have? We have x minus 2x plus 5. So, what do I see? I see 1, 2 linear terms. So this thing over here, 2 linear terms. 2 linear terms. That's what we have. So now we set up for 2 linear terms. A over x minus 2 plus b over x plus 5. So I use the first one twice. This. And obviously, since I have 2 different x minus c's, right? I have x minus 2x plus 5. So I will have 2 different constants to deal with this. So this is the setup. You look at the denominator, see what type of factors it has, and you assign appropriate formulas to each. Why do we have 2 parts? Because we have 2 of these factors here. You can have 7, in which case you will have 7 over here. That's what we'll see it later. Well, not with 7, but... So now, how do we solve this? Well, it's very simple. Find the common denominator here, and then both sides will have the same common denominator, and then you just equal the tops. That's all it is. So, as you cross multiply here, the denominator becomes x minus 2x plus 5, because we are adding these guys together. So we know that we just get these together and then cross multiply. So I have ax plus 5a plus bx minus 2b. That's it. And now, since denominators are the same, I can equal numerators. 9x plus 3 is equal to ax plus 5a plus bx minus 2b. All right, so now these guys are like terms, and these guys go together as constants, right? So I have a plus b times x, so that's the check mark terms, and then you have plus 5a minus 2b is equal to 9x plus 3. Compare coefficients, and we're done. So for the red equation, I have that a plus b is equal to 9, and for the blue equation, I have 5a minus 2b equals to 3. So you might be, what the hell happened here? Now we have a system we can solve and get A and B. That's all we need. But go back to the beginning of time. Good. So we have what we want to decompose. We see two linear terms. We use the linear guys to set this up. So with A and B. And then cross multiply to get them into common denominator, so this form and this form look the same, have the same denominator. Because this and this have the same denominator, that means the numerator must be the same as well, which is this equation here. Now note that both sides have x terms and both sides have constant terms. So all I did is I put the constant terms together. If I factor out x, I just get a plus b, right? So that's this times x. And then I have 5a minus 2b, which is the rest. Just pile them up. Equal to 9x, I just brought it to the other side, same thing. So 9x plus 3 goes here. In order for the left-hand side expression, all of this, to be the same to all of this, coefficient of x has to equal to coefficient of x, giving me the red equation, and the constant term that has no x has to be equal to the constant term that has no x, which is the blue equation. Do we see that? Make sense? Perfect, because we're going to do more examples and try to get it to make sense. Use whatever witchcraft you know to solve the system. I don't care whether it's substitution or elimination or you throw bones into the pan and look at it. I don't care. So times 2 on the top, we can do elimination. That's going to give me 2a plus 2b equals to 18. And then 5a minus 2b equals to 3. We add them. We have 7a equals 21, a equals 3. If a equals 3 and a plus b is equal to 9, then b better be 6. And now you just plug in those, so a over x minus 2 plus b over x plus 5 is actually a is 3, so 3 over x minus 2 plus 6 over x plus 5. There it is. Awesome, right? Now you know how to decompose. Now you know what to say when someone says, "What's new?" There you go. Quickly ask for paper and a pen so you can show off. So that's the partial fraction decomposition. And in general, it's kind of harder to start, but then once you get the hang of it, it really flies. I'm going to get more problems. No problem. And I'll do one more example, and then I will ask you to work on the example. So say we have to deal with x over x squared plus 2x minus 3. To decompose. This is problem 14. No, 16. So decompose. Well, the first order of business is to factor the denominator. And that is going to be x plus 3, x minus 1. If you're not good with factoring, use quadratic formula, because quadratic formula will give you the same answers. I see two linear terms again, so a over x plus 3 plus b over x minus 1. So I'm asking you to add these guys and then compare numerators, compare coefficients, and then done. Here are your steps. Let's see.
Did you get the same thing? Here, girl. I got the same thing. Okay, but my question is this part. That's the only part I asked you about. I don't think I got this one. I didn't, but I told you to look at it and I got the same thing.
All right, so I can sense some disturbance in the force, but you'll power through it. So the first order of business is to add these guys. So we are going to have x plus 3, x minus 1, and then ax minus a plus bx plus 3b. So now compare the numerators. I'm going to say that that's going to be ax plus bx minus a plus 3b, if I put them in order, equal to x. So that's the compare numerators. And then I'm going to factor x on the first one. So I have a plus b times x minus a plus 3b equals to, and I'll say x plus 0, because I can. Now, compare coefficients. Red with red and blue with the blue. So I have compare coefficients. A plus b is equal to 1. Coefficient of x is 1. The number in front of x is 1. The number in front of x on the left hand side is a plus b. So a plus b is the same as 1. Blue equation, negative a plus 3b is equal to 0. Solve. We add equations immediately. We have 4b is equal to 1, b is equal to a quarter, and if b is equal to quarter, a better be 3/4 so they can add to 1. Looking at the red equation. So, the x over x squared plus 2x minus 3 is equal to a is 3/4, so 3/4 over x minus 1, no, x plus 3, plus b is 1/4 divided by x minus 1. And that's it. So I'll go through it one more time, and then we'll do the next example. Take a look at something spicier. Behold the problem. We have x over x squared plus 2x minus 3. We have to factor that, if we can, right? Hopefully you can, because you can't do the problem otherwise. So you factor that, and then each of the factors is linear, not repeated, so we again have the first setup that is presented in our chart. And then we add these to get the common denominator so that we can compare this one and this one. So once we have those, we compare the numerators because denominators are the same. If you multiply both sides by the denominator, it will just be gone, and you have x equals this mess, which is this. Right? You have your ax plus bx minus a. So I just swapped these two terms because I wanted x's to be together and constants to be together. From the first two, we factor out x, and its coefficient we equal to the coefficient of the other side, which is the red equation. And then we have this part here, which is equal to the blue equation, right? So that's that, and the 0. So that's the blue equation. We already see that a and negative a are set up for cancellation as you add. You add them. B is 1/4 immediately, and then a is 3/4 because they have to add to 1, right? You can plug in 1/4 here. 1 minus 1/4 is 3/4. And there you go. So the problem is equal to 3/4, and we did decomposition, right? We went from having one equation, right, unfactored or anything like that, into these two terms, two rational expressions that we can go on and do whatever we need to do. Great. What happens if you have more variables? I mean, more terms? Well, more work. That's all it is. So, say you have problem 18, and you can practice 17 or something. So 4x squared minus 5x minus 15 divided by x plus 1, x minus 5. And now what I see are 3 linear terms, which means we are going to have 3 terms to set up with a, b, and c. One is going to have x as a denominator, plus b, it's x plus 1, and c with the x minus 5. So these are the ones. And then, well, now it's trickier to do our common denominator business, right, to add these, because each one is going to be missing 2 terms. So x term needs to be multiplied by x plus 1, x minus 5. b needs to be multiplied by x minus 5, and c needs to be multiplied by x plus 1. Obviously, numerator and denominator. So now multiplying this is becoming really labor intensive. But such is life. Oh, it's going to be much more fun on the lab. Allocate a few days. Compute. So, what do we have? We have a times, when you FOIL this, you get x squared minus 4x minus 5, plus b times x squared minus 5x, plus c times x squared plus x. If you FOIL those, or distribute, is equal to 4x squared minus 5x minus 15. So, distribute everything now. I don't like the plus. So we have ax squared minus 4ax minus 5a plus bx squared minus 5bx plus cx squared plus cx equals to 4x squared minus 5x minus 15. Oops. That's okay, it's okay. all of the x squared terms on a pile. So I have ax squared plus bx squared plus cx squared. That's one group. Plus the next group are all x terms. Negative 4ax minus 5bx and plus cx. And then finally all the constant terms, well, there's only negative 5a equal to 4x squared minus 5x minus 15. At this point in time, we factor out x squared on the first three. So a plus b plus c times x squared plus, factor out x, minus 4a minus 5b plus c x, and then minus 5a is equal to 4x squared minus 5x minus 15. So standard procedure, except it's messier, has more terms. But again, we are comparing coefficient of x squared with the coefficient of x squared, so that's my red equation, a plus b plus c equals to 4. The blue equation with the blue coefficient, which is negative 4a minus 5b plus c equals to negative 5. And finally purple, with purple, well, negative 5a equals to negative 15. Yay! I get a is 3. Immediately, a is 3. That helps a lot. If a is equal to 3, you can substitute a equals to 3 in the other two equations and make it a 2 by 2 system. This is happening rarely, but when it does happen, it simplifies calculations a lot. So now over here I have 3 plus b plus c equals to 4, which gives me my first simplified equation, b plus c equals to 1, when you subtract 3 on both sides. The second one is negative 12 minus 5b plus c equals to negative 5. And when that negative 12 goes to the other side, it becomes positive, so you get positive 7. So I have negative 5b plus c is equal to positive 7. Subtract equations. Equation 2 minus equation 1. And we got it. Minus 5b minus b is negative 6b. C is die, and 7 minus 1 is 6. So b is negative 1. Yay! B plus c have to equal to 1. So c better be 2. So equals to 2. There they are. What happened? Yeah. Minus 5 minus b because I'm subtracting. So minus 5 minus 1 is minus 6, right? C minus c is 0. And then 7 minus 1 is positive 6. So negative 6b equals to 6. So what's the answer? The question said 4x squared minus 5x minus 15 divided by x plus 1, x minus 5 is equal to 3 over x minus 1 over x plus 1 plus 2 over x minus 5. I just plugged in a, b, c into this top, right where they belong. So you see a and x go together, and b and x plus 1 go together, so I just replace the value where they go, and that takes care of that. Valentine. Any questions, concerns about the procedure? Exactly. If about 90% of you are not going, what the hell is going on? That means I'm not reaching those 10%. 10% of this classroom is like 3 students. There's nothing to learn here. It's a procedure, so just, you just deal with it. Let's see the way you deal with it. So try this one on your own. 2x squared minus 18, no coughing, x minus 12 divided by x cubed minus 4x.
Oh yeah, right. Nothing is just excited. Now I remember. Yeah, the problem
All right, let's work out this together. I hope you factored, right? You factored?
I know you were thinking like, oh no, it wasn't.
So we kick x out, and when you kick x out, you are left with what? X squared minus 4. Now x squared minus 4 can further factor into x minus 2, x plus 2. So this is the full factorization of the denominator. Numerator, you just copy. And this problem is the same as the previous one. We have a over x plus b over x minus 2 plus c over x plus 2. We multiply first one by x squared minus 4, right? When you multiply x minus 2, x plus 2. So that's x squared minus 4. And then this one xx plus 2. And then this one xx minus 2. Same for denominators. And once you multiply everything out, you get the common denominator of xx minus 2x plus 2. And then we have ax squared minus 4a plus bx squared plus 2bx plus cx squared minus 2cx equal to what we had before. So now, since denominators are the same, maybe I should use a different color here. So if denominators are the same, there's equal sign in between, right, everywhere. So if denominators are the same, numerators must be the same as well. So this is where we have our ax squared plus bx squared plus cx squared plus 2bx minus 2cx minus 4a equal to 2x squared minus 18x minus 12. Now, first three, a plus b plus c times x squared plus 2b minus 2c times x minus 4a is equal to 2x squared minus 18x minus 12. Red with red, which is the red equation. Blue with the blue, that's 2b minus 2c equal to negative 18. And purple with purple, which is negative 4a equals to negative 12. And we're lucky again, right? No need for, I don't know, black magic or whatever, because we have a is 3. Right off the bat, a is 3. Negative 12 divided by negative 4. And now, we plug that in here, so I have 3 plus b plus c equals to 2, which gives me b plus c is negative 1. And the second equation is already simplified. Times 2 on the upper equation to kill the c's. So 2b plus 2c equals to negative 2. 2b minus 2c is equal to negative 18. Add them up. C's die. And we have 4b is equal to negative 20. B is negative 5. So bring out b plus c equals, you can use any equation because you have a and b. To find c, there's a negative 5 plus c equals to negative 1, c equals to 4. So a is 3 over x, b minus 5 over x minus 2, and then plus 4 over x plus 2. So minus and plus? Yep, minus then plus. Now you can do the integration, you can do inverse Laplace transform, you can do all the bunch of other stuff that's coming in your later coursework. Right now it's just this procedure of figuring things out quickly. Fun? No? Nothing a few hours can sort out. Now let's try something new. So this one is going to have the quadratic piece. So this is problem 29, textbook. 5x squared minus 6x plus 7 divided by x minus 1 and then x squared plus 1. Setup. Setup is a over x minus 1. That's linear. We are used to linear. All we did so far is linear, right? And now you have a quadratic that you cannot factor anymore. Right? If this was x squared minus 1, then you can factor it and you use, again, linear parts. Now this is the quadratic that you cannot factor, which means you are using the bx plus c divided by x squared plus 1. Now, it's not repeated. Repeated one would have a square right here, right? We don't have that square. So this is it. This is the setup. You have one linear with a corresponding linear, and you have a quadratic with the corresponding quadratic. None of them are repeated. There are no squares, right? So we are done with the setup. Cross multiply to get ax squared plus a plus bx squared plus cx minus bx minus c, when you FOIL, divided by x minus 1 times x squared plus 1. That's when we find common denominator. So now I hope you see that the expression here and the expression here have the same denominators, so we can compare those. I'm going to write ax squared plus bx squared minus bx plus cx plus a minus c is equal to 5x squared minus 6x plus 7. So the first two, well, we factor, right? So a plus b times x squared plus negative b plus c times x plus a minus c is equal to 5x squared minus 6x plus 7. Equations. Red with red, so a plus b equals to 5. Blue and blue. So negative b plus c is equal to negative 6. And let's go with the purple. And purple, a is equal to 7. That's not purple. Can you tell the difference over there between green and purple? Right. Thank you. So purple is simply a equals 7. Well, if a is equal to 7, b has to be negative 2, and then the other one has to be negative 8, and we're done. But let's... So from the first equation, 7 plus b is 5. b equals negative 2. And then when you plug in negative 2, it becomes 2. So altogether negative 8. So this is 2. I mean minus minus 2, but it's right. And then plus c is equal to negative 6. So c is negative 8. So what was the whole thing? It's a over x minus 1. I lost my problem. Right, so a over, oh wait, I have a 7. Getting confused. There we go. Minus b, which is 2 over, oh no, it's a bx plus c, so plus 8. And before you jump screaming, observe the negative. X squared plus 1. That's the note that both c and b are negative. So what I did is I factored that negative sign right there. Otherwise, I would have to have negative 2x and negative 8 written in the thing. Yes?
Why didn't you include minus c when you're comparing the constants?
No. Because I missed it, and now everything is wrong. Oh, you write in pen? Well, you shouldn't. The purple equation is a minus c equals to 7. That's what the purple equation is. Great. Now we need to solve the system. Well, you know how to solve the system. Look at the... you can eliminate C by adding easily, or you can eliminate B by adding easily, or you can eliminate A's by subtracting. It doesn't matter which one you do. So let's eliminate C. I have A plus B is 5. And then when I add these two equations, I get a minus b is equal to 1. This is even better. So plus, that's 2a is equal to 6. Did I have a is equal to 3 earlier? No? It was 7 or something? Alright, so if a is equal to 3, b must be 2, and c must be negative 10. Because 3 no. If a is 3, it has to be negative 4, right? Alright, so that's x minus 1. So 3 over x minus 1 minus bx, so that's 2x. It's a plus. Minus 4 divided by 5x squared, 6x. Five x squared minus 6x plus 7. Yep, that's good. Another one? Wow, you guys are really interesting character. Ah, right in time. Okay, so we haven't done anything with repeating terms. So here's 26. 3x squared plus 49 divided by x plus 7 squared. So for the repeated, you have to use the second one from the list, right? The one that has a square. What the hell was that? Oh, I thought it was a math thing of the kind I haven't heard before. Like, okay, you can do it again. It's okay.
This is right. I'm guessing because this building doesn't go in the road. Because like if you do this, then it goes like this. That's what I'm thinking. No, but I'm forget what you're talking about. I'm talking about this alone will look like this because whatever we told you before that whenever this looks like this with the square, you can break it apart. And that's what I'm doing. This one I'm doing. All that work.
That's why I said everybody has our stuff.
Yeah, but I want to make like a break here. And so I'm getting it all here and then here. I don't care about that. And I'm going nowhere. That break, shut up, you say I'm the reason why. Oh, okay. Selective hearing, that's all I heard. That's what you say. Why is she over there? No, I mean, like, where's she on the news? Seriously? I'm not doing that this weekend. I'm doing that either Thursday or Friday. I have to scan out my schedule because I have to study for chem and I have to study for bio and all this other stuff. For what? Oh. Did I start you from my final when I did? Oh, that wasn't my final one. When I didn't even know that I had a midterm, I just like put my shit on.
Yeah, just put them all out.
This was like four. When I was, I forget when I did that. When did we do that? So then I guess the other one says she was freshman and they were bumped up for this and then the other one was to be. So how did she get bumped up? How did she get it? She played it. Obviously she wasn't on the team. I'm saying that they bumped her up like took a ton to play with her. That's what I'm saying that. So like it would make sense that she would be in one grade. Because she will be in one of our games. I don't know, but all I know is that when she started with us, I don't remember. All I know I don't know then, but all I know is that when she used to practice with us, and it was during the time where Carmen and Ashley were still captains and the rest were okay, so then, whatever. All I know is that when she used to come and practice with us, right? They were, because there was two actors on the team, obviously because the captain was there, and then they were also doing this TV, so like they didn't think like, I don't know, I guess they didn't know like they were like doing TV, so they started playing, I don't know if they were going to come up, like that, yes, so everybody started calling this TV, I think she got mad at it, right? Yeah. I think it doesn't make sense, how did she do that?
That's what I'm saying, it doesn't make sense because she's a freshman.
Like she used to practice it. Maybe we could never play games and get more exaggerated, but I definitely like to practice it. That's why I thought that they used to bump her
It kind of
up.
makes sense that she like she was the other guy's brother, so maybe there's no way to do that.
Like since they bumped up okay, not that they bumped up, but like she would practice with us. I mean that was when we bumped up last year and then Gia and then
It's awesome.
and then the other
We're
girl.
freshmen, so it makes sense. Yeah.
So I don't know. I just feel like she's I know who you're talking about. I just forgot what it was.
No, it's not. But here, in the beginning, the first steps.
I'm sketchy. All right. Let's take a look at this problem, and that will wrap up. Next class is the full class review. I hope you will have the packet, right? You will solve everything and bring questions. Any exams, anything that you need to know. So that's Thursday, and the final exam is next Tuesday. You have lab 4 due, you have your project due, and all right, the final. So it's like 50% of the grade on that day. Is it? Yeah, no stress, right? Because you have what? You have 30, and then 10 for the labs, and then 10 for the project, and then, yeah. It's like 50% in 2 hours. But that's okay. You got this. All right, repeated linear. There we go. So x is going to be using the first rule, which is just linear, and then repeated linear for the x plus 7 squared. Now, as we are looking for the common denominator, which will be x plus 7 squared, we have to multiply here by x plus 7 squared, x plus 7, and just x on the last one. All right, so what's x plus 7 squared? That's x squared, so ax squared, and then plus 14a x plus 49a. Don't forget the middle term when you FOIL. On the second one is plus bx squared plus 7bx plus cx. So now we equal the ax squared plus bx squared plus 14ax plus 7bx plus cx plus 49a to whatever we had, 3x squared plus 49. Great. So now I have from these three, and a single one. So a plus b times x squared plus 14a plus 7b plus c times x plus 49a is equal to 3x squared plus 0x plus 49. I want to put that 0x there so I have something for the middle. Red, which is a plus b, is 3. Blue is 14a plus 7b plus c equals to 0. And then purple, 49a is equal to 49. Oh, that's great. Unless you're gonna say, but what about? No, you won't say. So A is 1. Nice. Bring that in here. B is 2. So now we have 14 times A, which is 1, plus 7 times B, which is 2, plus C equal to 0. So that's 14 plus 14 is 28. C is negative 28. And a over x, so 1 over x plus b, which is 2 over x. Is it x minus 7 or plus 7? Plus 7. And then minus 28 over x plus 7 squared. Partial fraction decomposition. If the calculations get too crazy, you can use the calculator to find the system of, to find the solution. you can find on YouTube. Systems of equations, TI-83, gives you a video how to follow instructions and you do it. Good. Another one? That was quick. No. That's good. Well done. So this is on your lab. So hopefully you guys will have fun. And I will see you all in 2 days then.